Hey everybody, welcome back to our channel. Thanks for tuning in. Today we'd like to talk about our off-grid solar system and the power generation system that we have to power our house here in this remote area. As you can see, I have 6 solar panels behind me. I didn't construct this setup like this. I did come out here, just kind of gave it a once over. I got to understand the system and so that I can come out here and break it down for you guys. So what we have here is 6 panels that generate 1800 watts of power, and that's 1800 watts per hour that it can generate on its peak generating power that it can do on, say, a bright sunny day, unlike today. Today, being that it's cloudy like this, we're only bringing in probably about 150 watts of power per hour, which is not too much, not even enough to power most laptops these days, but it does cover the lights that we have in the house, being that they are only 9-watt LEDs. They're all wired in series here, and they are facing the south direction of our property. So in the winter we do get all the sunlight coming in here because it's low, and then in the summer they do have to get adjusted so that they can meet the sunshine that is hitting the panels a little higher. I do have the controller inside that I'll probably get to maybe this spring or summer that can track the sun. However, from what I'm gathering from the professionals who made these panels, they do not recommend the tracking anymore. With the cost of solar panels, they just recommend to get the extra solar panels, because you're only in reality going to generate an extra 10 to 15% with the tracker. So that being said, this does, on the bright sunny days, it does put out the power that it needs. We've been seeing 1400 watts per hour on optimal days. And the only thing that we have to do maintenance wise with this right now is come out here when the snow does fall quite a bit. It accumulates on the panels and then prevents the sun from coming in. So I just come out here with a broom that I attached a 10-foot piece of EMT to it, and so I can brush off the solar panels. When it is a nice bright sunny day and the panels get to heat up a little bit, I don't even have to come here. The sun will just melt it right off and take care of themselves. But as for now, we're still working with it and understanding the system, but for now, we haven't really needed to use the generators much. This has seemed to be doing well for us, and we're quite happy. We'll see how it generates in the summer. Some people say that the solar panels work better in the winter than they do in the summer. So we'll probably do an update later down into the year, letting you know how the system works in the winter as opposed to the summer. And go from there. So yeah, if you have any questions on the solar panels here that you think I've missed, leave a comment down in the comments section. That's right after you subscribe and hit the bell. So what we're going to do now is head over to the generator building and show you the generators that we need to turn on, just in case these panels don't put enough power out on a cloudy day like it is today. So let's head over there. Alright, so we're back here in the generator room. I have 2 generators in the generator room that I do use for backup power, just in case the solar panels don't work or they don't generate enough power for the day, or say a couple of days go by and it's all been cloudy and the batteries just need a good boost. We do have a Kubota diesel generator here. This one obviously is diesel, just as mentioned. However, it provides 240 volts back to the house if needed, and this thing will really produce some power. Another reason we do have this is, say you're in the shop and you're in need for a welder, you have a 220 volt connection right on the unit itself. So I can pull out this cord and connect up my welder or anything else that would require 220, and just run that out to the yard and go from there. But the cord that we have connected here now runs back over to this switch into the top, and this here is our Honda gasoline generator, and it only puts out 120 volts. However, this one puts out about 3,000 watts of power, and this one is many more. So typically we don't run this one, we just use this one because the most we're going to be running that needs anywhere close to 3,000 watts would be say like a blender or a coffee maker, electric kettle, but now that we have wood burning we don't use it at all. And our washer, we also turn this on just so it's not such a drain on the system. This one is a lot more efficient just because on the front of it here you can go on to full blast, or you can put it onto economy mode, which will kind of slow down the use of the gasoline, not put out the full 3,000 watts that's required. If you don't need it, say you're putting the draw on it, it will kick up into a higher gear for that brief second to use it, and then it'll cut back down. So this one is what we've been using the most. It takes about 15 liters of gas to fill it up, and out of that 15 liters we will get about I would say 9 hours of runtime on it if we need it that long. Typically we haven't used it for more than, I would say, 6 hours, and that was for a complete charge from empty right through to the equalization part, which your batteries are full at that point, but being that you need to run an equalization charge on it, which I'll get to when we're inside, the generator is required to run. So from both these generators I have a cord running back to this box, and now what we have at this box here is a transfer switch that the previous owner Jimmy rigged here. So it is safe, it works perfectly fine. However, it's not an actual transfer switch, it's just a double throw switch, which still acts the same way, I would say. So what you have on the front here is you got the Honda at the bottom, and then the Kubota at top. So depending on which generator is running, so say I fire up the Honda, all I have to do is come out here, flip the switch, down to Honda, and now the house is getting powered by the Honda generator at 120. And both of these are fed off of the tech cable here, and that runs right back to the house into the heart of the solar system that I'll show you in a second as well. And then inside the house also Jimmy rigged a little light switch that you can just flip in the down position, and it'll cut this generator out when the time comes, so that you don't have to come all the way outside just to turn the key to the off position. The only thing you have to remember is once you turn it off out there, just to turn it back into the on position, so that when you do come back out here, that the generator fires right back up with no issues. And if I wanted to run the Kubota for whatever reason, I just need to flip this over and it runs the rest. One thing I did also notice that the Kubota does that the Honda doesn't is power all the lighting in the generator room and in the shop. So in order for me to get that extra power into the shop and in this generator room, I do have to fire up the Kubota diesel generator. Not much to it really. Seems to be working out great. The other day I had to go fill up some 55-liter drums just to have fuel storage here. So one thing you're going to be looking at if you're getting into this type of situation is fuel stabilizers for both the gasoline and the diesel. The diesel should last a lot longer than the gasoline does. Gasoline will run out at max probably about a year, even with the fuel stabilizers, where I've heard guys get up to 3 years with the diesel. So that's one thing to keep in mind when you do have systems like this with both diesel and gasoline. So if you are looking at a backup generator, do keep that in mind. Also with the diesel generator, there's a little bit more maintenance. I gotta change the fuel filters on there. I gotta do oil changes on the unit itself. It does produce a lot more noise, so you don't run it running say at night when you're trying to sleep, because I don't know, for those that can't sleep, it might be an annoyance, but we don't have neighbors. I'm talking about myself. So yeah, other than that, I think I've covered everything here. Again, if you feel that I've missed something, leave a comment in the section and we'll get back to you. Other than that, let's go inside and take a look at the system inside that we have, the control displays, the inverters, the batteries. I'll show you the switch that I was talking about. That's at the back door, that you literally is a light switch and you just flick it on. So let's head over outside and I'll meet you inside. Alright, now that we're inside, this is the switch that I was telling you guys about that shuts off the generator. This one will only do the gasoline and not the Kubota. So the Kubota, being that you don't run it as often, I guess the guy figured that you didn't need it. But a nice little feature here, makes our life a lot easier. The only thing that is required is to make sure that's an up position for when you go to fire it up, because it's not nice when you go out there and it's in the down position and you're thinking, why is it not firing it up? So one thing you just got to realize with this thing, keep in the up position and you're good to go. So let's check out the controller here on the main level and then we'll go downstairs. And this is our controller that we can kind of view the status of the system, see what it's doing, how much power we have left, how much power is coming in from either the solar system or the generator. You can also kind of scroll through the meters here and look at your AC meters coming in, DC, what your hertz are. And then also if you go into timers here, you can see how long it takes to charge the batteries. You can go over to see the last day was equalized, which was done yesterday. And also the last day was on absorb. So you can kind of control the whole system from this little panel here. It's pretty straightforward to operate. You just have to read the manual, because there's so many different little settings in here and different little monitors that you can put on the system that this one doesn't have. So when I was actually going through the system the very first time, I was trying to get a couple readings on here and realizing I don't have the instruments on the system to actually give me the readings I'm looking for. So it's something that I might want to put in down the road. It's not really necessary right now. This gives me plenty of information and is very user friendly. Now let's head downstairs and check out the rest of the system, or where everything comes back to, and I can kind of let you know how all that comes together. So let's head on down. Alright, now we're downstairs, and this is the heart and soul of the system. The batteries are next to me over here, which I will show you after I run through this system. The batteries themselves are 6-volt, interstate, deep cycle, 232 amp hour batteries, flooded. They're not a gel or a lithium or any of that other. It's just a standard flooded battery. And over on this side of the board we have a tech cable that comes in from the outside that goes to the controller, which then in turn goes through your overload system here and to your inverter. And from your inverter it will send out or will take in a DC signal and send out an AC signal on this tech cable here, going back to a 100 amp panel, just like you would have in any other residential area. Now this controller here, I can also control the exhaust fan for when I do the equalization on the batteries, because they do create a very heavy chemical smell that is not too pleasant to smell, so that'll vent it outside. Also, this controller here tells me how much power I'm bringing in from the solar system. So being that it's cloudy outside today, I'm bringing in between 35 and 42 watts. It's telling me that the batteries are at 70% at the moment, actually 68, so it fluctuates depending on the draw and how much the power is coming in, right? So it's not always a steady charge in there during the day. So as you're using it, it's bringing it in, so it'll fluctuate a little bit like that. The overcurrent device here is pretty self-explanatory. Just make sure that you're not having too much power running through the system. And this here is the inverter, so this will take your DC signal from here and invert it into an AC signal, which will go back to your panel. And these here are the lines from the transfer switch for the generator, so no matter which way I flip that switch, be it the diesel or the gasoline, they come in on the same line and hook up to the one point here, and then this inverter knows how to transfer that over into the panel. Or what this will also in turn do is send power back through and charge the batteries. So you can run it either way. So if I'm running the blender upstairs, being that the signal, the power from the generator is coming right to here, it'll send it back there so that I can get my 1,000 watts on demand for a blender, or 1,500 watts for a electric boiler. That being said, when I don't need that power, this will send the power into the batteries, and upstairs that little controller, it will tell me what state the charge is in, and this would be the line for the controller, obviously going back into the inverter. Now we're going to go over here, just quickly talk about the batteries and the vent fan that I was just explaining to you that vents out the chemical gases. Other than that, this is there's a couple things that I see I would like to do better, like maybe put proper connectors on here, but in the scheme of things, it's very well done and I really can't complain. I understand, like when you're out in these remote areas, people do their own electrical, but I'm glad to come and see something that's decently safe in the house, and I don't have to worry about what's done in behind the walls or anything like that. So that is one thing to note when you do buy properties like this that are remote. There are no inspectors out in these areas. No one's really coming to check on what you're doing, so it's important to make sure that it's done correctly when at the time of purchase, because you don't know who's done it. Even in the city, you have people that will jimmy rig things and then they're burning down their house. So that was a really nice sight to see. So now we'll just head over here to the batteries and I think we'll wrap it up from there. All right, now that we're just over from the panel and the main system, over here underneath this box, or this cover here, are the batteries. And this was the fan that I was telling you guys about, that exhausts the fumes from these from this container here. So when we open this up, here are the batteries. We have 6 of them. Like I was saying, they're interstate 232 amp hour batteries, fully filled with the battery acid. They're 63 pounds, but they do have a little bit of weight to them. And they're a 6-volt battery, not your 12-volt battery. But the way they're wired is it's wired in a 24-volt system. So depending on how these jumpers are done, which again are very well done, they use the proper nuts and bolts on this. Nothing looks corroded. It's very well maintained, so that's not something nice to see. But from what I gather, they're about 2 years old, so they should be lasting us for a very long time. So there's nothing really special to this. The lines from here is your what's this? Your positive or negative, and your positives over there. They're going back to the panel, and yeah, that's about it. And then your vent pipe comes directly in there. So when this does bubble, this lid is closed, and everything gets vented out here, and outside, and we're good to go. And that's something that needs to be done every 60 days. So when we took this place over, it was I think 125. So it was due for a little equalization. Anyways, that's our solar system, or our power system for this off-grid home. If there's anything that you'd like us to touch on or kind of elaborate on, or anything that you'd really like to leave in the comments, just do so, and we'll get back to you as soon as we can. So thanks for coming to check out the video, and hopefully you got some good information from this, and we'll chat to you later. Take care.